Soleil at the MGM Grand in Vegas. Watch this. Used to do that in right field every once in a while. That's insane.
I've never seen that.
Kai is performing.
Hey class, so for our physics video, we decided to analyze the mechanics behind a baseball pitch, such as some of the ones you're seeing in this video.
We're going to show you why Yu Darvish of the Texas Rangers is in the major leagues and I am not.
And as my partner said, we're going to look at two technique differences that major league pitchers use to pitch much faster than the average baseball player. So right here we have footage of Jarrett's pitch. So here we have the pitch again, played at a quarter speed.
So we put the video into Tracker and we found that my pitch had a velocity of around 36 meters per second, which is around 80 miles per hour. And this gives the ball a kinetic energy of 94 joules.
素晴らしいストレートでしたけどもね。しかも150キロ連発で。
寒くて体が動かなかったという話だったんです。水浴、そしてバルディリスといった外国人選手に対してきっちりと。
Let's compare my pitch with an actual pro. This is Yu Darvish. He's one of the greatest Japanese baseball players of all time. And his maximum fastball speed is around 42.5 meters per second at release, which translates to 97 miles per hour or around 131 joules of energy. This is a video of Yu Darvish pitching his fastball at the 2009 World Baseball Classic.
And as we will analyze through this video, two things that pros do to gain a mechanical advantage when pitching is one, increase their stride length. This factors in with work because they're increasing the distance on which they're applying a force to the ball. Secondly, they bend their elbow 180 degrees or parallel to the field, and this allows them to apply a greater torque to the ball versus perhaps 160 degrees.
Obviously, there are other factors that affect pitch velocity, like muscle strength and the optimization and flow of trunk rotation, but stride length and arm angle are two factors we can actually discuss with our knowledge base.
As you can see in this pitch right here, Jarrett's arm angle is approximately, give or take, 150 degrees. So we know that torque is your cross product between your radius and your force. In other words, you can view it as the radius times the force perpendicular. In a baseball pitch, your elbow is your fulcrum and your forearm is your radius. So if you can increase the angle of your pitch, making it 180 degrees or parallel to the field, you're increasing the perpendicular force vector, and therefore you're applying a greater torque to the lever, which would be the arm. Actually, the reason that a greater angle improves the pitch speed is we have to go look at angular velocity. Angular velocity is the change in theta over the change in time. Therefore, when a pitcher pitches, they're not really looking at, oh, I'm going to release the ball after 0.03 seconds. It's kind of an intuitive motion, and as humans, we don't think, or we can't really calculate time in such a small scale. However, what we can do is increase the angle of our pitch. That's something that a lot of pitchers really focus on and look at their own footage for. So if we're going to increase the angle, we're increasing theta, and considering that we cannot manipulate our time and the time stays the same, a greater angle in the same amount of time is going to yield a greater angular velocity. A greater angular velocity will then equal a greater angular acceleration, and then if we analyze angular momentum, it'll also yield a greater angular momentum, and therefore a greater torque.
Okay, so we all know that work is the force applied on an object over a distance. And in this case, it's the work done to a baseball, the force applied on that baseball, and the distance over which that force is applied. And in this equation, we can see that by increasing your stride length, you increase the overall distance of which the ball is having a force applied on it, which in turn increases the work done on the ball, which increases the kinetic energy of the ball. This is one reason why Darvish's fastball is almost 20 miles per hour faster than mine.